And okay, let us evaluate the integral x sine x dx. Now notice that this is a product of an algebraic function and a transcendental function. So this is a good candidate for integration by parts. And there's actually no obvious substitution that will help us in evaluating this integral. So first let us recall, what's the formula for the integration by parts? Now recall that we need, if we can take the integral of u dv, that should be equal to uv minus the integral of v du. So what we need to do is establish what we have to choose. We have to choose which one of this would be which of these two functions, x or sine x, will be our u, and which one will be which one will be u, and of course the remaining parts now will be now the dv. The technique, or there's one simple technique to remember, is that if you want to find your dv, it should be something that you can easily integrate. So in this case, looks like this is a good candidate for u. That means this is our dv. And this is how I like to write it. Now let me start with dv. So if dv is equal to sine x, if dv is equal to sine x dx, then what is v? How do we find v? Well, that means we simply have to integrate. We simply have to integrate sine x dx. And what's the integral of sine x dx? So the integral of sine x dx is equal to negative cosine x. Now we don't need to bother with constants for now, so we just take this. We just leave it as it is. We don't need to add any constant for now. And that gives us the value of v. So hopefully you remember how to do this. Now, so that's our v. Now what about the u part? The u is equal to x. So that means du is simply equal to dx. Now why do I like to write it this way? Well, it helps me find my answer eventually by simply following a pattern. Now let me just rewrite this. So remember, we're taking the integral of x sine x dx. So this is u dv. Our pattern, so we now have our u dv, so we need our u times v. So u times v, so we just follow this direction here. So we have x times cosine x, don't forget the negative sign, minus the integral of v du. So we just go down this way. See this part here? There we go. So it's nice one. You just follow this motion here. So u times v minus v du. Integral of v du, that is. So negative cosine x dx. So we have negative x cosine x. So what do we have so far? So what is, can we take the integral of this now? What's the integral of negative cosine x dx? Or okay, we can bring out the, so this is the same with, or this is equivalent to integral of positive plus integral of cosine x dx. So what is the integral of cosine x dx? So that is sine of x. And now we add the constant. So there you go. That's how you find the integral of, this right here, the integral of x sine x dx using integration by parts. And how do we know that we get the correct answer here? Well, what you can do is find the derivative. Find the derivative of x cos negative x cosine x plus sine x plus c, and verify